This is the Managing Microsoft SQL Backups Using Intelligent Policies lesson. This is the 6th lesson in this course. In this lesson, you'll learn about the functions, components, and terminology of Microsoft SQL Server. You'll learn to configure NetBackup for SQL Server Intelligent Policies. You'll learn how to monitor SQL Server backup jobs and how to restore SQL Server. This is the Introduction to Microsoft SQL Server topic. SQL Server is Microsoft's enterprise-grade relational database. NetBackup supports multiple versions of SQL Server ranging from 2005 through SQL Server 2014. This slide shows a high-level overview of a SQL Server. The Windows host Server A is the physical SQL Server itself, and the physical host has one or more instances of SQL Server running on it. In this example here, looks like 2 instances. Each instance has a master database, which contains the most critical metadata about that instance, and several other system databases, and we'll describe in detail in a few slides exactly what those are for. And it also contains some user or production databases, shown here as DB1 through DB5. This slide shows the components of a SQL Server database, at least the primary components, the ones we're most interested in as backup administrators. Now, the database consists of tables, and the data that's in those tables is stored in data files. The primary data files, the ones that were created when the database was first created, have an MDF extension. SQL Server uses a different extension, NDF, for secondary data files, which were added later. For example, if there's growth in the database and additional files were needed to support it. Like most enterprise relational databases, SQL Server uses transaction logs, which have an LDF extension. All data incoming to the database hits the transaction logs first before it's applied to the data files. Data files can be organized into file groups by the database administrator, and a database will always have at least one file group with at least one primary data file in it. SQL Server supports replication by using log shipping, meaning that copies of the transaction log are replicated to another SQL Server in a remote site, and then a log replay is performed so that the secondary database server is maintaining a replica, a read-only copy of the data on the primary database server, in case the primary server ever fails. This is useful for availability. It helps you get back online faster if anything bad ever happens to the primary database server. Note that the way SQL Server operates, backing up SQL Server requires write access to the database, specifically to the transaction logs. And that's not possible for the replica, so it is not possible to protect the secondary database server. Backups must always be performed on the primary database server. This slide reviews some terminology used with SQL Server. The SQL host is the name of the actual SQL Server itself. Might be a cluster name or might be an IP address. The SQL instance is one specific SQL Server installation, and again, a host may have multiple SQL Server instances running on it. Transaction logs are where all of the incoming data is applied to before it's applied to the data files. ODBC, Open Database Connectivity, this is an industry standard for accessing relational databases. ODBC is used by NetBackup for some of its interfaces with SQL Server. NetBackup also makes use of VDI, the Virtual Device Interface, which is an interface that's provided by Microsoft. It's a SQL Server proprietary interface, which is specifically designed for backup and recovery. So a lot of the stuff that NetBackup is doing with SQL Server goes through this VDI interface, but some actions are taken using straight ODBC. This slide shows NetBackup terminology used with SQL Server. Traditionally, SQL Server databases were protected using batch files, which is a series of commands given to the database to do backups and restores. Legacy SQL Server backup policies still use batch files in the same way that other database agents like Oracle use scripts to perform backup and recovery. Now, SQL Server Intelligent Policies, which are a recent addition to NetBackup, allow for the creation of single policies that can protect multiple SQL instances or databases across multiple clients that automatically generate batch files at runtime and eliminate the need to prepare these ahead of time, and that support traditional full differential and transaction log backup schedules rather than having database-specific application schedules. Full backups contain all the data and log files for a database. Differential backups contain the changed blocks since the last full. Note specifically the terminology here. We're using differential in what I might describe as the Microsoft way. Microsoft apps tend to use this term differently than NetBackup does. So a differential backup is actually more like a cumulative file system backup would be. And then transaction log backups, or TLOG backups for short, back up the inactive portion of the transaction log, and typically we truncate them after they're backed up successfully. As with other database agents like Oracle, doing continuous backups of the transaction logs allows us to do recovery up to the point of failure and allows us to do hot backups of the database. And so it's desirable to keep the inactive portion of the transaction log around and back it up on a regular basis. Note that unlike some databases like Oracle, which have archived redo logs that are totally separate files from the online redo logs, SQL Server doesn't do this. SQL Server just has a log file that has an active and an inactive portion, and it keeps track of that by making marks in the file, and it's the inactive portion that we'll be protecting. Other terms that you see used here, a backup stripe is the ability to send multiple streams of data from the database to NetBackup. So striping is very similar to multiple data streams that would be used with a file system backup. It's very similar to using multiple channels to back up an Oracle database. Same concepts, just different terminology. And when it comes to the recovery side, there are two actions that make up a recovery of a SQL Server database, as with most relational databases. The restore is where we actually copy data back to the SQL Server. The recovery is when we apply incremental backups and do a roll forward of the transaction logs to apply historical transactions to bring the database to an online and consistent state. Two of the main components that are used by NetBackup in protecting SQL Server, the graphical user interface, dbbackup.exe, is used to browse database objects and backup images. It can create batch files that can be used for legacy backups or for restore or move operations. The driver, dbbacx.exe, is what actually launches backup and restore operations. And so batch files that have been created to back up or restore the database can be executed using this driver. Here's a look at a database instance, and we're looking at it using the Microsoft SQL Server Management Studio user interface. And so underneath the database instance, we can see that the databases node, that there are system and user databases. The master database records all the system level information and critical metadata about the database. Protecting the master database is an essential part of your data protection strategy. In a lot of ways, it's sort of analogous to protecting the control file on an Oracle database. The MSDB database is used by SQL Server for scheduling alerts and jobs. The model database is used as a template for the creation of other databases. You might or might not want to be backing that one up, depending if you've made any modifications to it. And then TempDB is basically a scratch pad where SQL Server stores temporary information. TempDB is never really backed up. It doesn't even persist across restarts of the database instance. It's purely temporary data. And then when it comes to the user databases, we see here there's one DB test, and we can drill down and see in the Studio interface the components of that database. In this case here, they've expanded the tables node, and we can see different tables in the DB. One of the tasks that's very relevant to the backup of the database that's performed from this interface is to change the recovery model of a database. You see, for a particular database, we can right-click and go to Properties, and then change its recovery mode. Full recovery mode means that inactive portions of the transaction log are retained until they are protected by a backup application like NetBackup and then truncated. And that's what we want if we want to do hot backups of the database and provide the best recovery point right up to the point of failure. In simple recovery mode, on the other hand, the inactive portion of the transaction log is not retained beyond database checkpoints, and so hot backups of the database are not possible. The bulk logged mode is usually a temporary state that the database is put in if there's going to be some large-scale bulk transactions which might generate excessive logging. The DBA might switch the database from full to bulk logged mode so that some of those transactions weren't captured in the log, and then when the bulk operation was complete, switch it back to full. Most of the time, most databases will be in either the full or the simple mode. This slide reviews some of the major capabilities of the NetBackup agent for SQL Server. In this lesson, we're going to cover the basics of protecting a SQL Server database and recovering the database, as well as how to manage and monitor backups. Now, there's always more information that it can't be covered in the time we have allotted. For additional detail about any of the operations in protecting Microsoft SQL Server, refer to the NetBackup for Microsoft SQL Server Administrator's Guide, which has more detail. As we've discussed, the traditional way to protect SQL Server databases is by using what we now call legacy SQL Server policies. And that means that batch files were created, which was a complex operation. You had to understand the terminology being used by the database. The graphical tool would help you out a lot, but it was still potentially an error-prone activity and almost involved a lot of cooperation from the DBAs to get these batch files created. And it was difficult to protect multiple instances, and it made use of these database-specific schedule types, the application schedule and the automatic schedule. And so a major improvement to protecting SQL Server came with the advent of intelligent policies. Intelligent policies automatically discover SQL Server instances and databases and automatically generate the batch files necessary to protect them. You basically just need to select which objects you want to protect from the graphical interface. And then the schedule types of fulls, differentials, map more closely to the traditional schedule types that are used in regular file system backups. And you have options from the intelligent policy to set some of the SQL Server specific policy attributes that in the past you would have had to be done by adding logic to your batch files. Our focus in this lesson is going to be on using intelligent policies. For more information about the legacy policies, refer to the Managing SQL Backups Using Legacy Policies appendix. This is the Configuring NetBackup for SQL Server Intelligent Policies topic. Intelligent policies are robust and easier to set up than legacy SQL Server backups. There are a few limitations to mention before we get started. Intelligent policies for SQL Server do not support SQL Server mirroring, clustering, or always-on availability groups. Specific to SQL Server 2014, in-memory databases are covered for the whole database only, and file group and file-based backups are not currently supported in version 7.7 GA. As discussed previously, our focus in this lesson is on SQL Server intelligent policies, which we recommend using if at all possible. The information about legacy SQL policies is covered in Appendix B, Managing Microsoft SQL Backups Using Legacy Policies. NetBackup automatically discovers SQL instances. To view discovered SQL instances, under the Applications node in the NetBackup Admin Console, navigate down to Microsoft SQL Server. You can see here we have the All Instances node selected, and we can see 2 database instances in this example that have been discovered. If it was not possible to automatically discover SQL Server instances, manual instance discovery is possible. With the Microsoft SQL Server node selected, I go to Actions and then Discover Interfaces. I can also manually add SQL instances by going to Actions, New, and then Instance, and providing the details about the database instance I wish to add. Once SQL Server instances have been discovered, they need to be registered with NetBackup, so that NetBackup has the correct credentials to access the database. Now, some criteria here. The user that's going to access the database needs to have the SQL Server sysadmin role and must be a member of the local Windows administrators group. And we're going to configure logon account for the NetBackup client service and the NetBackup legacy network service, and that can be either the SQL system administrator or local system. These services don't have to use the same logon accounts, they could be different ones, but the accounts used must have privileges to impersonate a client after authentication and to replace a process level token. Here's an example of registering a SQL instance. Under All Instances, I go through and right-click on a particular instance and select Register, and you'll see I have a number of options here. I can add this instance to an instance group, and then all of the instances in that group will use the same credentials, or I can use credentials that are defined locally on the client, or I can use specific credentials that I enter here. These credentials will be protected with AES level encryption and stored in the NetBackup database. Here's the high-level steps for configuring NetBackup for SQL Server database backups. First, make sure I verify any installation prerequisites in the NetBackup release notes and the SQL Server Administrator's Guide. Make sure my license key is in place, the SQL Server license, which is called the application or database pack if you're using traditional licensing. In some cases, the snapshot client license may also be required. Calculate the number of simultaneous jobs that may be running at any given time, multiplying the number of objects times the number of stripes configured times the number of policies. And then make sure that the maximum jobs per client limit in the NetBackup host properties supports this. And I can then proceed and configure SQL Server intelligent policies. Here's an overview of the information that's present in each tab of an intelligent policy. In the Attributes tab, we're going to set the policy type to Microsoft SQL Server, and we're going to set the destination, the storage unit, and if I'm going to tape, the volume pool. And then I'm going to create schedules. Schedule types are full backups, differential incrementals, which back up the change block since the last full. Again, be careful with the terminology there. And transaction log backups, which are backups of the T-logs. On the Instances and Databases tab, I'm going to specify which SQL Server instances and which databases are being protected. And in the Backup Selections, I specify which objects in those databases are being protected, either the whole database or just parts of it. And then options, SQL Server specific options, are contained on the Microsoft SQL Server tab. Over the course of the next few slides, we'll walk through the creation of an intelligent policy. First off, on the Attributes tab, I make sure that the policy type is set to Microsoft SQL Server, and I set the storage destination. Next, I'm going to create backup schedules. As with regular file system backups, the schedule determines what kinds of backups are going to take place and when they're going to take place. So it looks like in this example here, I've got a full backup schedule that's running on a frequency once per week, and I've set a backup window Saturdays 2200 to Sunday 0400. Then I've got differential incrementals, which are going to run weekdays with a start window 2200 to 0200. And then I've got very frequent T-log backups every day between midnight and 8 p.m. at a frequency of 4 hours. It's not unusual for those T-log backups to run very frequently. They may run even more frequently than that in a busy production environment, because remember, in addition to backing up the transaction logs, at least the inactive portion of them, this is also the trigger to truncate those logs and prevent the logs from consuming too much disk space on a database server. It is oftentimes necessary to back up and truncate these logs frequently to conserve disk space on the server. And of course, the more frequently I back them up, the better my recovery point is. Here's an example of selecting the type of schedule: full, differential incremental, or transaction log. Here's an example of configuring the start window for when this particular schedule is allowed to run. Now, if I wish, I can also set exclude dates using the exclude dates tab, and those would be specific days when this schedule is not permitted to run. On the Instances and Databases tab, we select whether we're going to be protecting instances or instance groups, or whether we're going to specify clients for use with batch files. Note that that last option there would basically convert this from an intelligent policy into a legacy SQL Server policy. So going with the example on the slide here of protecting instances, here are the instances that have been registered with NetBackup. By using the string all for database name, it means that which databases will be protected is determined at backup time. Essentially, all of the databases in that instance, with the exception of tempdb, will be protected. And that's nice because it means that databases can be automatically discovered when the backup runs. The instance state controls whether or not the instance is backed up when the policy executes. Instances that are in the active state are protected. Instances that are inactive are ignored when the policy executes. And so maybe it's desirable at certain times to take an instance offline for maintenance. Here's an example of using instance groups instead of individual instances. So by having the policy target instance groups, this means that all databases in all instances that are members of that group, except for tempdbs, will be protected, and any instances that are added to the group are automatically protected by this policy. The Backup Selections tab allows us to specify which database objects will be protected. You can see by default the first option there is the whole databases, which means all file groups, all files, and the inactive portion of the transaction logs. Now I could be more granular if I wish to back up just specific file groups or just specific files, and you see in the example here how I can browse to discover specific objects. The Microsoft SQL Server tab allows you to set SQL Server specific backup options. On the left-hand column, Database Options applies to full and differential backups, while the right-hand column, Transaction Log Options, applies to T-log backups. This is the Monitoring SQL Server Database Backups topic. This slide shows an example in a NetBackup Activity Monitor of running a SQL Intelligent policy. And so we see job number 99 is a discovery job that resolves instances to clients, retrieves the credentials for the databases from the NetBackup database, and generates the summary job, job 100. This is responsible for actually generating the batch files and executing them. And then based on the execution of those batch files, backup jobs are going to be created. Job number 101 and later, and these backup jobs are the ones that are actually moving the data. These are stream-based backups from SQL Server to NetBackup. Here's an example of what we'd see in the detailed status of the summary job. Now remember, the summary job is responsible for generating and executing the batch files. So the kinds of thing we're going to see here are the number of operations that were generated. Still looking at the details of the summary job here, if we scroll down a little bit further, we can see information about the execution of each of these operations that was generated. And then at the end, a summary showing the number of successful and non-successful operations. This slide shows some considerations about SQL Server. Remember that SQL Server is doing replication via log shipping. We're always going to back up the primary SQL Server. we're unable to back up secondary servers because those databases are in a read-only state, and SQL Server requires write access in order to do data protection. Always-on availability groups is not yet supported as of 7.7 GA. And in a multi-interface network SQL Server environment, configure the policy with private interfaces in the client list, add permissions to enable browsing of backups across the private interface, and if it's clustered, set the public interface name and the SQL Server connection properties in the NetBackup Microsoft SQL Server client interface. This is the SQL Server Disaster Recovery Considerations topic. The restore of SQL Server databases and objects is done using batch files, and these batch files can be generated by the NetBackup for SQL Server graphical user interface, which is available from the Start menu on all NetBackup clients. So I open the graphical user interface, and this is a very minimalistic interface when I first open it. It'll literally just be a blank white square. The first time you open it, you'll be sitting around waiting for more stuff to appear, but that's it. It's a clean slate. So what you want to do is go to File, and then Restore SQL Server Objects, and then select the SQL host and the source client, and then select the time filter, which is basically a date range for which backup images you wish to browse. I'm now presented with a listing of backup images that have been created, and I can select which image I wish to restore. The icons differentiate full backups, differential backups, and T-log backups. So I select which items I wish to restore, I select any restore specific options, and then go ahead and click the Restore button. This slide shows various combinations that are available when selecting backups to restore. And note that when I select an object to restore, if there are any dependencies, then they will be automatically selected as well. So in the first example in the upper left, I'm selecting a full backup to restore, no dependencies there. In the second option in the upper right, I select a differential backup image to restore, and so the corresponding full backup is also automatically selected. In the third example, bottom left, I'm selecting full plus a T-log backup. So in this case here, it's probably that I want to restore the database to a specific point in time before the incremental backup. And so I'll restore the full, and I'll restore the transaction log. The last example, bottom right, I'm restoring the full, the differential, and the applicable transaction logs. So in this case, it looks like I want to bring myself as up to date as possible. And so you'll notice that all of the transaction logs since the differential backup are automatically selected. Any transaction log backups that are before the incremental are not selected because they're not necessary. Here's a closer look at some of the restore options for full backups. So you notice under the scripting section, I can choose to restore an object or to create a template for later use. In particular, I can create a move template here, which is used to move a database from one host to another. That's a commonly requested service that oftentimes people will put in tickets for the backup team to do. And in SQL Server, moving a database from one server to another is accomplished via the restore process by creating a move template. And then you'll see I have other options here for whether the database will be recovered or not, and whether consistency checks will be performed or not. As with most relational databases, once the recovery step is performed, a roll forward is done of the transaction logs to bring the database to a consistent state, and when recovery is complete, no further restores can be applied to that database. The consistency checks are an option. It's kind of a trade-off here. Consistency checks make for better verification of data, but the more thorough the checks I do, the longer it will take the restore to run. Here's an example of the restore options available when I'm restoring transaction log backups. You'll notice in the recovery section, I have the option as to whether or not to recover the database after this restore is complete. And again, once the database is recovered, no further restores can be applied against it. I also have options under transaction log recovery options to what point in time I want to recover the transaction log. If I want to try to recover everything that's there, or if I only want to recover up to a certain point, identified either as a point in time or by a transaction log mark. In this lesson, we've tried to cover the basics of protecting Microsoft SQL Server data and running restores. There's a wealth of additional information about NetBackup for SQL Server, which covers a lot of other cases that we didn't have time to cover in this lesson, available in the NetBackup for Microsoft SQL Server Administrator's Guide. In this lesson, you were introduced to Microsoft SQL Server and NetBackup for SQL Server terminology. You learned how to configure backups of SQL Server using intelligent policies and how to restore SQL Server objects. This concludes Lesson 6.